Hello, it's Valentine from Simplistic, and in this reaction we have to calculate delta G naught for this reaction, but we're given three different reactions and we have to calculate it by combining these reactions. So essentially we're going to basically combine these three reactions in such a way so that they kind of add up to form this reaction. So let's go ahead and do it. So what we need to understand is, number one is, in this reaction we have an N2O on the reactant side, and we have N2O in the third reaction out here as well. The only difference is that out here I have 2 and out here I have 1. So that should tell me, and I'm going to just put this in red out here because I'm thinking about it. Maybe I'll put it in black out here because I'm thinking about it. Let's put it in red because I'm thinking about it. Maybe I should be dividing. So my strategy out here is going to divide this by, let's write that out here, divide by 2, and then take a look at the first reaction out here. The first reaction, we actually have NO on the left hand side, and out here in the reaction we're supposed to get, we have NO on the right hand side. Okay, so that means I have to take this reaction and I have to flip it. So my strategy is going to be to flip, and then what we also need to understand is that I have 3 NOs on the right and I have 2 out here. But look at the NO2. I have 2 NO2s out here and I have only 1 out here, and there's no NO2s anywhere else in all these reactions. So that means I need to flip plus divide by 2. So I'm going to flip, let's write that out here, flip and divide by 2. And then if I look at the second reaction out here, I notice the N2 and the O2, they don't have any correlation with this, but the NO is on the correct side out there. So we're going to leave that as is. Okay. All right. So let's go ahead and apply that strategy. So if I flip the first reaction and I divide it by 2, that means the delta G naught of the reaction for the flip, the sign will change. So that sign will become positive. And then if I divide by 2, if I divide the reaction by 2, then this gets divided by 2 as well. So that transformation gives us delta G naught of the reaction is equal to 35.6 kilojoules, and then the reaction itself becomes NO2 goes to NO plus half O2. All right. For the next reaction, I'm going to keep it as is. So I do N2 plus O2. Forgot to add the phases out here. Let me just erase that and do it properly. And this has the delta G of the reaction. The same value goes down here. And the third one, we decided to divide by 2. So if I divide by 2, I get N2O goes to N2 plus half O2, and delta G naught of this reaction is equal to minus 103.7. Okay, so that value goes down to there. Okay, now let's go ahead and add these all together and see what we get. So once I add them, my N2s cancel out, my oxygens cancel out. Okay, and finally, let's see, I'm left with N2O plus, sorry, I wrote that wrong, N2O plus NO2, both in the gaseous form, gives me 1 NO out here and 2 NOs out there, so that's 3 NO in the gaseous form. And if I add the delta G's, That gives me 107.1 kilojoules. There you have it. I hope that made sense. Thank you for watching.